Good evening, students. Are you able to hear me?
Yes, sir.
So yesterday we discussed the concepts till impulse, right? And we did a problem also based on it. So is there any doubt from yesterday's concepts that you guys have?
Sir, can you once more tell the definition of impulse alone?
Sure. I'll show you here itself. You can make the product of force and time, which is a change in momentum of the body, remains a measurable quantity, and this product is called impulse. Okay. So generally, when they ask you what is impulse, you have to say the amount of force acting, and you have to calculate the duration of the time and the product of both. So what is the definition you will give? Tell me. To be honest, nobody will ask you what is the definition of impulse. Okay. But you tell me what is the definition, you will give it in your own words if I say there is a physical quantity like this. Try it out. It is a product of
Force and the time.
it is a you can put it more in a polished way. It is it is a product of force and the duration for which the force is acting. Can we say it like this?
Yes, sir.
So you can say it like that is how anything is defined. Okay. Similarly,
Yes.
a large force acting for a short time to produce a finite change in momentum is called as impulsive force. Okay. Shall I proceed?
Yes, sir.
Is it clear? Okay. Now,
Yes.
we did a problem, right, based on this concept. Shall we try out one more problem, guys? This is an important problem. Okay. Let's try this out. There are two identical billiard balls which strike a rigid ball with the same speed but at different angles, and they get reflected without any change in speed as shown in figure 5.6. So, okay, I need to speak about the Newton's laws also. Okay. So they ask what is the force exerted by the ball on the ball. So the next concept that we are going to discuss is after impulse is Newton's third law. And I'm sure everybody knows this. So what is Newton's third law, guys? Every
Action has equal and opposite reaction.
yes. So every action has an equal and opposite reaction in the direction of its application. Correct? So write it down. Every action has an equal and opposite reaction in the direction of its application. So what do I mean by direction of its application? Because force is a vector quantity. In whatever direction you're trying to apply a force, right, there will be an equal and opposite reaction that is going to take place. Provided all the forces are balanced, right? That is what you meant by, or we can put a system like this. For a balanced system, there is an action and there is equal and opposite reaction, which is okay. One minute. Sorry, guys. Cut the statement. For a balanced system, every action has an equal and opposite reaction. So here, what do I mean by equal? Equal in terms of magnitude. And opposite in terms of direction. Because force is a vector force. I hope it is clear, right? Now, suppose I take a block and try to push it against a wall. If I name the block as A and the wall, there's not a mirror, okay? And the wall as B, then if I apply a force in this direction, what can I name? How can I name that force as? If I call that force as capital F, then I will write FAB is equal to minus of FBA. What do you understand from this statement?
Force of A with respect to B is opposite to the force of B with respect to A.
Okay, only addition that I need to do is I need to put a vector symbol on top of it. So this is force applied by A on B, and this will be force applied by B on A. Are you guys able to understand? So if I call this as action, then this thing will be the reaction. Okay. So reaction has equal magnitude and opposite direction. That is why I put a negative sign. So this is the basic significance of whom? Newton's third law. Okay. That's it, guys. It's a very small introduction. We'll understand it better when we solve more number of problems. So I hope you guys have marked this as important. Right. Now, shall we try this problem? There are two billiard balls which strike a rigid wall. One, the same ball with the same speed but at different angles and get reflected without any change in speed. So the question is very clear. Without any change in speed, what do they mean?
The surface is frictionless.
No, nothing to do with frictionless. I didn't introduce the concept of friction at all. It's very simple. Don't overthink. Any other attempt? You want to try to give a different perspective? I want you to understand what is the meaning. What does this kind of physics vocabulary mean?
Energy is not transferred, sir.
Energy and all, right? Energy also I didn't speak till now. No. Any change in speed meaning in it? The magnitude of velocity is constant, but there is a possibility the direction might change. That is what I understand from this diagram. Okay, so wherever you see, I want you guys to change the perspective. Okay, so wherever you see the word speed, the first thing that should come to your mind is speed is the magnitude of velocity. So when they talk about change in speed, the magnitude of velocity is constant. Means there is a possibility of direction to change, because this can be an assertion reason question. Like, for example, I frame a question like this. There is an object which is in uniform circular motion. Okay. I give a statement one like this. Velocity of the object is same. Statement two. Speed of the object is same. What will you say? What do you understand from this statement? What do I mean by velocity of the object is same?
Both their magnitude and direction is same.
Is that correct? For a uniform circular motion, if this kind of a statement is given, is statement one correct? Is it correct or wrong? You guys think and tell me. What is confusing you? Is there anything that you guys didn't understand in uniform circular?
Statement 2 is correct. Statement 1 is not correct.
Perfect. Statement 2 is correct. So what do I mean? In statement 2, I'm trying to say, yes, direction of velocity can change, but the speed is constant. But when I say velocity of the object is same, I'm trying to say that the direction and magnitude is same. But what is happening at every instant, the direction is changing, no? Correct, Ada? Are you guys able to understand? A very small thing,
Yes,
but
sir.
an important, right? Because you guys have assertion reason, please be very careful with all these small details. As shown in figure 5.6. What is the direction of the force on the wall due to each wall? You guys tell me. I'm hiding this. You guys think and tell me. So, during the time of collision, okay, during the time of collision, the first thing that you need to check. So, you need to develop your thought process right from here. There is another keyword given, rigid. Okay. So, what do you mean by rigid, guys? So, what do you
The
mean by
wall
rigid?
doesn't
What
move
do you
when the
understand?
ball strikes.
Okay, that is there. Does it have something to do only with motion? Suppose this is not a wall. Okay, there is a wall which is made up of, let's say, I stick clay on top of it. Okay, what am I sticking? Let's say I made a layer of clay and I put on top of the wall. And if I throw the ball, can I say that the clay surface is rigid?
It acts
You know
as
what
a
happens
cushion.
with it? No. Forget about friction. Forget about friction. Rigid has nothing to do with friction.
Sir, rigid mentions that
Good
the ball
that-
will bounce back.
So can you repeat? Can you come again, please?
Sir, rigid mentions that the ball will reflect or bounce back.
Okay, it is reflecting. It is bouncing back also. But my question is, can I say that the surface of clay is rigid?
No, sir.
No, sir.
Why? Because what is the important property that clay has? It can change its shape. Right? See, for example, let's say there is a metal sheet like this. On this metal sheet, if I drop a stone, what will happen? You will be able to see a bump like this, right? So the metal sheet will change its shape depending on, like, let's say, a weak metal sheet. It will change its shape, right? So, according to physics, rigid means any object that does not change its shape on experiencing force. Please write it down. So, according to physics, rigid means any object is said to be rigid if it does not change its shape upon experiencing force. Okay. So when this billiard ball is hitting this wall, there is a high possibility. Had it been a metal sheet, it would have changed its shape. So, but they are saying this wall is so rigid that it does not change its shape. Only under this scenario can I say, now try to visualize it, guys, on a microscopic level, right? At the instant or where these two objects are coming in contact with each other, can I say something like this? When the ball is in contact with the wall has a velocity in this direction, so it will apply a force of FAB on the wall, and two identical billiard balls, they told, right? I'm assuming that the billiard ball is also rigid. In that scenario, can I say FAB is equal to FBA, guys? Can I say that?
Yes, sir.
Because this is happening at what instant? At the instant the ball is in contact with the wall. So this is also technically called as at the instant of collision. Correct, Ada? Now, what is their question? Their question is very clear. What is the direction of the force on the wall due to each ball? So in this first scenario, the force experienced by the wall is going to be normal to it. Is it not perpendicular? Normal means perpendicular. So the wall is like this, it is perpendicular. That is FAB. Right. So they ask direction. Direction means angle. Similarly, in the second case, what will happen? When the ball is coming and hitting it like this is the direction in which the momentum is changing. So what will be the angle at which the force is experienced by the wall, guys? How much is this angle? Is that not 30 degrees? Vertically opposite angles. So when it is 30 degrees, so what will you say? How will you write the answer? It will experience a force at an angle 30 degrees with respect to the normal, with respect to the wall. Oh, sorry. This is 30, this will be 30. No? So it will experience a force at an angle 30 degrees with respect to the normal drawn to the wall. Guys, are you able to understand? Is there any confusion?
Clear, sir.
Yeah, right. Okay. Now I want you guys to think on how to solve the second part. The second part is what is more important. The ratio of the magnitude of the impulses imparted to the balls by the ball. So wherever a question is asked based on impulse, what are all the required data, guys? What is the required data for it? So whenever they talk about impulse, what are the two formulae that comes to your mind?
Force and the duration of time.
That is one of the formulae. Force into time.
Or else final and initial momentum.
That is change in momentum, right? So in this problem, with the data you have in your hand, do you think you can apply the first formula or the second formula?
Second
Will you
one.
be able to apply the first? You have to apply the second formula, right? Whereas when you're applying the formula, right, you need to be careful with the directions. So that is what I'm going to teach you now. I want everybody to concentrate. Okay. 100. Listen, please. Now see, if this is the mass of the ball, right? I'm talking about case 1. Okay. So what is the direction of initial momentum? What is the value and direction of initial momentum? Tell me.
Along x-axis.
M into U, can I write it as I cap? Because I'm taking this direction as I cap, this as J cap, and this will be minus I cap. Whereas with respect to the first one, it is a one-dimensional position. Right? Initial momentum is mu I cap. Final momentum is?
Minus I cap.
Very good. Mu minus I cap. Then what is going to be the change in momentum? It is final minus initial. So I'm going to get minus mu I cap minus mu I cap. So what will I get, guys? It is minus 2 times mu I cap, or the more mature way of writing is 2 mu in the direction of minus I cap. Means, is this not the impulse, guys? So how will you report the answer? Impulse is equal to 2 times mu in the direction away from the wall, or in the leftward direction. In the direction left of the wall. Can you say this? Right? This is a simple thing. It is something similar to the problem that we did yesterday. Correct? What about the second one? So second one is where you need to be careful. Because what is happening? It is a An example of two-dimension collision. See, I'm assuming that there is no doubt in case 1 base. Shall I proceed?
Yes, sir.
Yeah, good. So if this is 30 degrees, how much is this? Is this not going to be 60 degrees? Right. So do you guys remember resolution of vectors? If this is U, if this is 60 degrees, if this is M, okay. So if you resolve this into two components, what are the two components you are going to get? Tell me with the positive sign or the negative sign as well.
So the vertical component is u cos 60.
And horizontal is U sin 60, obviously. Because I told you wherever angle is involved, there you will write it as cos, etc. But tell me the direction. Vertical is a downward or upward?
It's upward.
It is downward. It is downward. And what about U sin theta? I'll tell you why it has come. It is downward. And what about the
U sin,
downward?
it's positive x-axis.
That is indeed rightward. Okay. So if you guys want to see how this resolution is done, it is like this. Guys, this is a very, very important concept in physics because you will be applying it throughout the concepts wherever vectors are there. So it is like this. For U cos 60, you should rotate this vector in the clockwise direction. So look at the arrow mark. Now you are able to understand why it is used cos 60 in the downward direction.
Sir, or else we can draw the x and y axis as the tail of the vector, right?
Yeah, you can do that, but if you remember it, well and good. Okay. Similarly,
Okay,
for this one, you will rotate it anti-clockwise. That is why the arrow, look at the arrow mark. So that is why they are in that direction. I hope you guys are convinced. Right. Now, this is for the upper object. This is before collision. Sorry, before collision. Now, what will happen after collision? So after collision, the object is going to come out in this direction. This is also U. Now, if I break it like this, this is going to be 60 degrees. Now you guys tell me that. Resolve it into two components. U.
Sir, y-axis will be u theta of cos 60.
Cos 60. This will be U sin 60. Directions. Horizontal is
Negative x-axis.
very good. And vertical is
Negative y-axis.
Negative y axis.
Negative y-axis.
that's it. You guys have understood. Very good. Okay. Now see along x-axis. What is the initial momentum? What is the initial momentum along x-axis? P stands for momentum, I stands for initial, x stands for x-axis. Mu sin 60, Mu sin 60 I cap. Now what about P final along x direction? It is Mu sin 60 along negative y direction. Similarly, along y-axis, what will the answer be? Mu cos 60. Mu cos 60 degrees minus j cap. And what is the final momentum along y direction? It is Mu cos 60 along minus j cap. So what will be the value of delta P initial? This is P P final along x minus P initial along x. That is minus 2 mu sine 60 degrees along j cap. Okay. What is the delta P along y direction? It is
2 mu cos 60 minus j cap.
0. There be no change. Calculate and see mu cos 60 minus j cap plus mu cos 60.
Sir, isn't it y axis?
Y. So it will be 0. Okay. So the only change in momentum is taking place along x direction. That is 2 mu sine 60 is root 3 by 2 of minus j cap. 2 and 2 will get cancelled. Root 3 mu of minus j cap. Okay. So that's the answer, guys. Any other doubt, guys? Is it clear?
Sir, can you show from the starting? Just show.
Where? This part, huh? Or this part?
Sir, previous
talking
page. Can you please show the previous page also?
Sir, along x axis, isn't it I cap?
Did you write j cap? Okay, sorry.
Yes, sir.
1 minute. This is I cap. This is I cap. I cap. Now is it fine? So root 3 times mu. Yeah. You guys let me know once you complete. Guys, let me know once you're done. Are you done? Somebody asked me to show this page.
Yes, sir. Yes, sir.
Is this fine? Done? Okay. So, but they asked the ratio, no? So, what is the ratio, guys? Ratio is 2 mu divided by root 3 mu. So, cancel them. Answer will be 2 by root 3. Maybe this can be an objective type question.
Sir, what about I cap? The first case, is it minus or plus?
There also it is minus 8, here also minus 8. But I think they ask the ratio of the magnitudes of impulses. But they will not ask
Oh,
you the
yes,
ratio
sir.
of vectors. They will not ask you. If the question is asking the ratio of the vectors, it is wrong because there is no concept of division of vectors. Okay. That's it, guys. So this is all about a problem based on impulse, and I suggest you guys to practice it again because it's a very good problem and it involves a lot of resolution concepts. Okay. Next is let's try out these problems. First, let's try these problems. 5.8. Do it fast. I'll give you 2 minutes time. Do it fast and tell me what is the answer. So there is a constant retarding force of 50 Newton which is applied to an object of mass 20 kilogram, moving initially with the speed of 15 meters per second, how long does it take for the body to stop?
Sir, is it 6 seconds?
How did you get it? So force is 50 Newton, mass is 20 kilogram, acceleration is equal to F by M. So 50 by 20, it will be, am I right, 2.5 meters per second square. Did you get this?
Sir, no,
Now
sir.
you
I
apply the
did it.
Yes, sir.
You use what formula? So V is equal to U plus 18.
Sir, because
0 is equal to. Your voice is breaking. Sorry. 15 by 2.5. That is 6. 6 is correct. But I'm not sure if you did in this method.
Sir, what I used was F equals ma and A equals V minus U upon T. So V is 0 and U is given.
Okay. It's the same thing. Okay. Try the next one. Answer please. So what is the acceleration?
Sir, 0.18.
How much? So acceleration is equal to V minus U divided by T. 3.5 minus 2 divided by 25. So it will be 1.5 divided by 25, correct? 3 by 2 means 3 by 50. Acceleration is 3 by 50 and mass is 3. So answer will be force is 9 by 50 Newton.
0.18 Newton.
Yes, sir, I got the same answer. Along the direction of initial velocity.
Yeah, along the direction because the object is accelerating. Correct? Its speed is increasing. That is the reason. Next. Now try the. Is there anyone who didn't understand? Can I assume everybody is clear with it?
Yes, sir.
Yeah, let's go to 5.7 guys. Do it fast. You're doing good. Do it fast. Answer, guys. So what formula are you applying?
F by M.
Parallelogram of addition.
We need to apply parallelogram.
Sir,
what are the
how
forces?
to
What are the
determine
net force?
the direction, sir?
Oh, direction means angle. Good that you asked. So 5 kilogram is there. 8 is acting here. 6 is acting here. Did you understand this thing? So there is a
Yes,
mass
sir.
of
Yes,
5
sir.
kilogram which is acting. There are two perpendicular forces. So resultant will be like this. So how did you know that it is parallelogram law of vectors? Because the two vectors that you have in your hand are co-initial vectors. Correct? So resultant will be 10. I hope you guys found it by now.
So magnitude is 2 meter per second.
8 square plus 6 square. Correct. 8 square plus 6 square plus 2 into 8 into 6 into cos 90 degrees. Okay, cos 90 will be 0. So root of 8 square plus 6 square obviously is going to be 10. 8, 6, 10 are Pythagorean triplets. Right. They're asking what is the force? Acceleration. Sorry. So force is 10
Yes,
Newton.
sir. It's 2.
Force is 10 Newton, correct? So F is equal to ma. A is what they're asking. 10 divided by 5 is 2. So I told you already, when they ask direction, what are you supposed to do? Take the angle as alpha. And you know that, you remember that formula, right? Tan alpha is equal to b sin theta by a plus b cos theta. Right? So generally,
Yes,
when
sir.
you have perpendicular vectors, right? This is what you do. You take alpha, right? So whichever is the vector that does not include alpha, take that in the numerator, and the one which includes alpha, take it in the denominator. So answer will be 3 by 4. So tan alpha is equal to 3 by 4. So alpha will be equal to how much? Tan inverse of 3 by 4 with respect to whom? With
The
respect to
direction
the
of force with magnitude 8 Newton.
with respect to 8 Newton. That's enough. So tan inverse of 3 by 4 with respect to 8 Newton. That's it. That is how you report the answer. Okay, but tan inverse of 3 by 4 is actually 37 degrees. Actually, it is 36.8 degrees, but you can write it as 37. I think I've already told this value. Sin 37 is 3 by 5, cos 37 is 4 by 5. Am I clear, guys? Nobody is having a doubt, right? Okay, I want you guys to try the next one. So the driver of a three-wheeler moving with a speed of 36 km per hour sees a child standing in the middle of the road and brings his vehicle to rest in 4 seconds, just in time to save the child. What is the average retarding force of the vehicle? Secondly, the mass of the three-wheeler is 400 kilogram and the mass of the driver is 65 kilogram. Try to do, guys. Let's see how much you're able to solve. Guys, is there anyone who is not clear with the previous problem? So the driver of three-wheeler moving with a speed of 36 km per hour sees a child standing in the middle of the road and brings his vehicle to rest in 4 seconds, just in time to save the child. What is the average retarding force on the vehicle? The mass of the three-wheeler is 400. So how to do, guys?
Sir, is
First
it
find the axis.
1150 Newton?
Not sure. I don't remember the answer. V is equal to U plus 80, correct? V is 0, U is 36 km per hour is 10 meter per second, plus acceleration is what we don't know. Actually, it is negative. Why do we need to put negative here? Because it is retarding 4 seconds. Okay. So acceleration is 2.5. So force will be equal to mass into acceleration. How much is the mass? 465 into 5 divided by 2. How much did you say?
1150.
When you multiply this, are you getting that? So 1000, but this is the procedure you followed, right? 1150 Newton is the answer. But I think it should be more than 2, Lada. No, it's correct.
Sir, opposite to the direction of the driver.
What are you saying? The force, sir? Did they ask direction of force? It is only magnitude, but yeah, direction will be opposite because the object is retarding. Object is moving in this direction, but
So then
retarding
it
force.
should be minus, right?
You need not write minus. They clearly mention what is the average retarding force on the vehicle. Unless they mention direction, you need not write the minus on this.
Okay, sir.
Unless it is mentioned in the question, it is always magnitude only. Okay.
Yes, sir.
So 5.9, you guys try this. A rocket with a lift-off mass 200 kg is blasted upon with an initial acceleration of 5 meters per second square. Calculate the initial thrust of the blast. Just multiply both, you will get the answer. That's it. Not a big problem.
Sir, the answer for the previous sum is 1150, sir.
Yeah, 1150.
Sir, but by multiplying 465 into 2.5, I got it as 1162.5, sir.
Sir, it's 460, right?
No.
465.
65, Lada.
Sir, then the answer is 1162.5.
162.5. Okay, then this is the answer. 162.5. I didn't check that, but I was
Yes, sir,
concerned about the concept. Okay, so it is 460. Okay, and predict its position. Okay, we'll try that 5.10 also. Try the 10th one, make it fast. There is an object of mass 4 kilogram moving initially with a constant speed of 10 meters per second to the north, is subjected to a constant force of 8 Newton directed towards the south for 30 seconds. Take the instant the force is applied to be t is equal to 0. The position of the object at the time x is equal to 0. Okay, the position of the object at that time to be x is equal to 0, and predict the position at t is equal to -5 seconds, 25 seconds, and 100 seconds. So here -5 seconds means don't get confused, the time is negative. Okay. So -5 means what happened 5 seconds before that 8 Newton force was applied. So let's first understand the logic. Let me try it out. I want you guys to discuss with me and do. Okay. You suggest me how am I supposed to do this problem? You give me ideas. Tell me how to do. So first, let's collect the data. Given mass is 0.4 kilogram. Speed, the initial velocity or initial speed mean the same. 10 meters per second in the north direction. So it is given initially it is moving with a speed of 10 meter per second. Okay. So I'm taking this position to be x is equal to 0, at t is equal to 0. At this instant, what is happening? There is an 8 Newton force that is acting on the object, and that 8 Newton force is directed in the south direction. And this 8 Newton is acting for a time period of 30 seconds. Take the instant the force applied to be t is equal to 0. Okay, all these things we got. Okay, tell me guys, are you clear with what is the question? Right. So this is actually, if you see this problem, right, this is actually a problem based on the equations of motion only. Okay. But instead of giving you the acceleration directly, they asked you to calculate the acceleration on your own. So what is going to be the acceleration of the object? Force divided by mass. It is going to be 20 meters per second square with a negative sign. Why negative sign? Because the object has a velocity and acceleration in opposite direction. Am I clear? Right. So if you take this as the reference, so 5 seconds before, okay, 5 seconds before this force was applied, what would have been the position of the object? So position of object at
Minus 50 meters.
Yes. How did he get it? Displacement is equal to speed into time. Why? Because the object didn't accelerate in those 5 seconds. So it is 5 into the speed with which it is moving. It is going to be 50 meters. So it was 50 meters behind the point x is equal to 0. What will be the position at t is equal to 25 seconds? S is equal to ut plus half at square. U is 10, t is 0, sorry, not 0. T is 25 plus half into, what should I write? Minus 20 into t square, 25 square, this will be 10. 250 minus 6,250, it will be minus 6,000 meter. What is this minus 50? So did you guys understand what is the meaning of this minus 6,000 meter? The object will no more be able to proceed in the direction of north. It will start moving in the downward direction. Okay, here negative sign indicates that the position of the object with respect to x is equal to 0 is in the southward direction. What is the next time they ask? T is equal to 100 seconds. Sir. I hope you guys can calculate it. But 1 minute wait. V is equal to u plus at is there. Let's calculate the time at which the object will come to rest. See, because, wait, I forgot to check one point. Guys, are you able to understand? There is a retarding force acting on the object. Whenever there is a retarding force acting on the object, then there is a high possibility that the object will come to rest at some point of time. Right? So I'm going to calculate the time at which the object is going to come to rest. 0 is equal to 10 plus minus 20 into t. So t is equal to half second. Did you
Sir, it
understand
should
what
be
Did I make any mistake? 10 divided by 20 is another. V is equal to u plus 80.
no, sir,
V is
correct,
0.
correct, sir.
Correct only, no? So means from the instance that 8 Newton force is applied, the object will come to rest in how much time? In 0.5 seconds. Means whatever is the distance traveled by the object in the next 0.5 seconds will be the distance at 25 seconds or 100 seconds. Guys, are you able to understand what I'm trying to say? So, at t is equal to half second, object comes to rest. So, calculate the displacement of the object in the next half second. So, s is equal to ut plus half at square. So, u is 10 into t is half plus half into acceleration is how much? Minus 20 into 1 by 4. So, 10, this will be 2.5 and this will be 5. So 5 minus 2.5 is 2.5 meter. Means after half a second, it will travel a distance of 2.5 meters and stop. So what will be the position of the object at 25 seconds or 100 seconds? Wait. So when it is stopping here, then when it is stopping after a distance of 2.5 meter, now what will happen? The object will be subjected only to a constant. The object will be subjected to a constant.
Sir,
Tell me.
sir, could you show how it's 2.5?
S is equal to ut. So the instance the force was applied, its speed was 10 meter per second. Into the time is half second plus half into acceleration is minus 20 into 1 by 2 the whole square, that is 1 by 4. So it
Understood,
is
sir.
5 minus 2.5, 2.5. So it has, after traveling a distance, it was able to withstand its velocity only till a distance of 2.5 meter. After 2.5 meter, what happened? Here, the velocity is 0, means for the remaining part of the journey after those half second, what will happen? The object was traveling under a constant retardation. Guys, are you able to understand what I'm trying to say? After half seconds, object comes to rest, and post half seconds, object moves under constant retardation. Okay, so when it is moving under a constant retardation, now tell me guys, after (25 seconds), what will be the distance traveled by it? S will be equal to ut plus half at square, but here u is 0. Why u is 0? Because for the next part of the journey, the initial velocity is 0 and half into acceleration is minus 20 into. So when did the initial velocity become 0? After 0.5 seconds, correct? So they're asking what is the time after 25 seconds. So in the first half seconds, it has traveled a distance of 2.5. So our work is to calculate what would have happened in the next 24.5 seconds. Guys, are you able to understand this? This is a slightly tricky problem.
Sir, why is the initial velocity 0 when time is 25 seconds?
No, I'm saying. See, they ask in t is equal to 25 seconds, right? So this is at t is equal to 0. Okay, the 25, I'm breaking it as 0.5 and 24.5. Observe why. When I take it like this, okay. So what does the stopwatch show here? It shows half seconds, half a second. In half a second, how much is the distance the object has traveled? 2.5. Are you with me till this point? Are you able to understand till this point? So after traveling a distance of 2.5 seconds, v is becoming 0. Now its direction is also changing because there is a constant force acting in the downward direction, south direction. So out of the 25 seconds, I understood what has happened for the half second. For the next 24.5 seconds, starting from this half second, is the initial velocity not equal to 0? So the initial velocity, I'm trying to break the journey into two parts, the forward direction and backward direction. When the object is moving in forward direction, after 2.5 meters, after moving a distance of 2.5 meters in half a second, it is coming to rest. So in the backward direction, okay, in the backward direction, what is happening? So how much is the time, extra time it is supposed to travel to complete 25 seconds? It should travel a time of 24.5 seconds. So in those 24.5 seconds, this will become the initial condition for that motion. So in the initial condition of backward motion, can I say that the initial velocity is 0? That is the reason I took u as 0.
Okay, sir. Okay.
Okay. Now you square this value and multiply with 10. That will give you the required answer. Once you get it, okay. So once you get that value, let's say the object has traveled this much distance. Okay. Now, are they asking the distance traveled or the position of the object? When they say position, they are talking about displacement only. Okay. So let's say this value comes out to be y. From that y, you are supposed to subtract this 2.5 so that with respect to x is equal to 0, this is the distance they are asking. This is the position of the object. It is slightly complicated, but I hope that you guys understand. Did you guys understand the logic? That is more important for me. Okay. Are you guys clear with the logic? Okay. In a similar way, can you do it for 100 seconds also? For 100 seconds, what are we supposed to do?
Sir, it's 99,000 meter minus 99,000.
Minus how much, sir? Minus how much? Can you repeat it? I'm not able to hear you. Sorry.
99,000, sir.
99,000 meter by calculating this value. Huh?
No, sir, I meant when t is 100 seconds.
Oh, 100 seconds you calculate. But did you subtract the 2.5 there?
Sir, can you please do for 100 seconds also? Sir, I was not able to understand, sir. So
What is there? See, nothing. You have to break it into two parts. That's it. Okay. So for 25 seconds, this is t is equal to 0. T is equal to half seconds if the object is here. So this will become the initial condition. This will become the initial point for the next 24.5 seconds because the total distance, the total time that they've asked is 25 seconds, correct? So out of 25 seconds, this half second is gone. So for the next 24.5 seconds, can I say that this is the journey?
yes, sir.
This v is equal to 0 will become the initial condition. It is similar to this case, Ra. There is an object which is projected in upward direction. So during the upward motion, you will take this as the initial velocity, no? But during the downward motion, you will take the velocity here as the initial velocity.
Okay,
Are
okay,
you able
sir.
to understand?
Yes, sir.
The
Yes.
same logic is what I have done. Okay. So for 100 seconds, what you do is instead of 24.5, you should write it as 99.5 seconds.
99.5.
Then try to solve the problem. Whatever answer you are getting, okay, whatever answer you are getting, from that answer you should subtract the 2.5. That will give you the required answer.
Sir, what about UT, sir? In
Which
when we
use again 0. No, why I took 99.5 is half seconds it has already traveled here. From here, I need to see what is going to happen for the next 99.5 seconds.
sir, okay, yes, sir.
Got it?
Yes, sir.
Sir, I have a doubt, sir.
Please tell me.
Sir, initially when we calculated with the formula like s equals ut plus half at square, without taking without breaking into two parts, so like we can calculate like that also, right? At t equals 100 seconds.
For minus 5 seconds, sir. For minus 5 seconds. Are you talking about the minus 5 seconds?
No, sir, not minus 5 seconds. For 25 seconds, how we calculated.
You can directly
I
calculate
didn't
t is
take
equal to
this.
24.
Okay, you didn't. But the conditions are changing. See what is happening. Here the object is moving in forward direction. Here the object is moving after after that half second, the object is moving in backward direction. That is the reason I was concerned to take all these points. If you calculate,
No, sir, like
are you getting?
we can take that s equals initial velocity is 10 meter per second from the
You can do
starting.
that. Yeah, what is the displacement you are getting? You can do that actually. If you take
So
S
with
as
that only,
displacement-
I'm getting minus 99,000.
Okay. check what is the answer. Just a minute. So what is the problem number? 10, right? My device is this. Do one thing. No, you guys have the study material in your hand, right? Everybody has it, right? You can check there will be solutions available in it.
So or else like we can calculate also, sir. Like Q is 10 and T is 100.
Let me check it again. Let me think about it. But there is a logic I got in my mind. Let me check if that will also work. Okay. So I guess you have another class, right? Even I have another class. I'll check and I'll get back in the next class. Next class we'll start with this problem itself. Okay. I'll see you guys.
Thank you, sir.
Sir?
Yeah.
Sir, the
Yeah, please.
second month payment, is it done through online or we have to like come differently? Which is
Thank
Which
you,
one?
sir.
Mark, this